Okay, so our problem today is we want to find the derivatives of inverse functions, and we're primarily aiming at finding derivative of inverse trig functions. But there's a general principle here about inverse functions. So suppose we have a function f, and we have a value x that's in the domain of f, and when we apply f to it, and then apply the inverse function, that the inverse function is well defined, and that it knows to bring back it pulls back f of x to just one value, x. So it's got to be a one-to-one kind of situation there where it knows what to pull back. We've seen with the arc sine that we had to actually limit ourselves to just a few angles that it pulls back range values from sine, because sine maps values from -1 to 1, and arc sine pulls back angles only from -π/2 to π/2. So suppose we have that scenario here where we have a value x, and we've written the identity f inverse of f of x is equal to x. Okay, and what we want to do is take the derivative of both sides. Now on the right side, I'll do that one for you quickly. That's going to be 1. Rate of change of x with respect to x is 1. The slope there is 1. On the left side, there's a lot of symbols and it can get confusing. We need chain rule. Matter of fact, we always need chain rule, but here we definitely need chain rule. So we're going to take the derivative of the outside. The outside function is f inverse, and the inside function is f, and the very inside function is x itself. So we chain our way in. So we have the derivative of the f inverse evaluated at the value f of x times, and then we move in, we chain in, the derivative of f at x times dx dx, which is 1. So we rarely write that, and that's all equal to 1. Now, suppose the derivative at x of f is not 0, then we can divide, because if it is 0, this actually, we get what, 0 equals 1? That's not even true. So suppose this is not 0 and we divide by it. So now we have a statement that involves the derivative of f inverse in terms of 1 over the derivative of f. The only trick is that usually if we've got some inverse function and we talk about its value somewhere or its derivative's value somewhere, we have a specific value in mind. It's not going to be the x that's in here. It's going to be the f of x value. So instead of thinking of x as the value that we started with and f of x as the value over in the range, we want to think of x being the value we start with that we apply f inverse to, and the other value is the one x pulls back to, f inverse. And we've got this really nice statement here that says that under the right conditions, the derivative of the inverse of a function evaluated at some value x is equal to 1 over the derivative of the function evaluated at the inverse function of x. Let's take a trig example and see how that works out for us. Okay, so we'll move that up there, and let's take the example of arc sine. Now I'm going to start typing a little, maybe help slow me down a bit, okay? So what I want is the derivative, let's see, escape, dd, escape, of, with respect to x, let's use t so that we don't get into a rut with x. And well, actually we have t here, so we should go ahead and use t. So we're going to go arc sine of t. All right, so we want that. What does this formula say? Well, if you're trying to take the derivative of the inverse of something, an inverse function of something, it should equal to 1 over the derivative of the original function evaluated at the inverse value. So let's try to unwind all that in this specific case. So it should be 1 divided by the derivative of sine, which is cosine. That's the derivative of sine, which is cosine, evaluated at arc sine of t. Nice, huh? Now here's where it kicks in an earlier video, chunk video, of what happens when you apply trig functions to the inverse trig functions and they don't align. Like the sine of the arcsine just gives you back the value, but what about the cosine? Actually, I did the specific example in there. What is the cosine of arcsine of t? Well, it's going to be equal to 1 over, do you remember? The square root of 1 minus t squared. Wow. So look, here's a derivative. We've got a formula that we might not ever want to work through that again. So we probably remember in our heads that if we see something like the derivative of arcsine, it's 1 over the square root of 1 minus t squared. And if someone says, why is that? And you might say, well, it's because when you take the derivative of inverse functions, you often end up with a trig function of some form being applied to an inverse trig function, but they're not the same function that you're taking the inverse of. So in this case, it's the cosine of the arcsine, and that always ends up with things like 1 plus something squared, or 1 over something square root, or x over square root of 1 plus x squared, all sorts of things. It's all according to what those two pairs are. So taking the derivative of inverse trig functions gives me trig functions of inverse trig functions. Okay, I'm going to throw another video in here. I think deriving derivative arctangent in a different kind of style and fashion. And remember that when you're doing antiderivatives, you work this backwards. That you start here and you work that way. Beautiful stuff. Hope that helps.